and Thomas Wohlgemuth will already continue the topic that we started now to discuss, climate change and different proveniences, etc. In a presentation that is called Tree Species to Keep Up with Climate Change, comparatively tested in 57 plantations in Switzerland. So a very interesting point here with a direct link to Wolfgang's overview. Thomas, the floor is yours. Please share the screen. And again, my ask to the audience, please put in your questions into the chat function. Thank you very much.
Do you see my presentation?
Yes, we see it in the presenters mode.
Ah, yeah, okay.
So you can start it.
Excuse me. Okay, good morning.
Excellent.
Good morning, everybody. Thank you very much, Florian and Katharina, for inviting me for this conference. I'm very happy to be here. And it's also very special to talk in front of about 70 different screens. This is new. I will hold this presentation in combination with two of my colleagues. The majority of the content of this presentation is from Peter Brang, who is the coordinator of this test plantation in Switzerland, and Daniel Scherer, who produced some of the maps I will show in the following. The situation in Switzerland regarding non-native tree species in forests is a bit less complicated than in other adjacent countries to Switzerland. We only have a percentage of 0.57 of all tree stems of non-native tree species. Of these 0.57%, about 40% goes to Robinia pseudoacacia, black locust, and to Douglas fir, Pseudotsuga minziesi. So these two are the most widespread non-native tree species in Swiss forests. Now, during the climate change, I again can repeat the problem and visualized by distribution maps of tree species along the Alpine arc. For instance, European beech and Norway spruce is shown here on this map as its current distribution, current presence. Beech which is prevailing in the lowlands and up to 1,200 meters above sea level, and Norway spruce mostly prevailing in higher altitudes. By the year 2050 to 2080, projections show that the suitability of beech will disappear from the lowlands and climb higher up to higher elevations. And also for Norway spruce, the suitability will decrease in the lowlands, for instance, also all in Germany, where it is widely planted, and climb higher up to higher elevations, even higher as today's tree line. For the broadleaf species, here two examples, oak and common hornbeam, they are widespread in lower elevations in warmer regions, and they will, by climate change, also increase the suitability in the inner alpine valleys and even climb up a slope uphill in these regions. So suitability will climb and shift towards high elevations. In regard to forest community, this means that the current situation of widespread broadleafed forest communities in the lowlands and coniferous forest communities in the Alpine arc, they will shift also towards a wider spread of these broadleafed forests and a shrinkage of the distribution area of coniferous forests. And there is interesting problem here. If looking at the uncertainties of the climate projections, here is indicated in black color all the regions where we will face a climate that has no comparison to current climates in our country. So this means at the lowest places and in some places, in some valleys of the Alps, we will face new climates that our ancestral tree species have not encountered so far. So this means the problem arises which species can there thrive within the next 50 to 80 years if the climate will change that much, that higher temperatures will prevail and changes of seasonal precipitation peaks. To maintain the ecosystem service, and in particular the forest ecosystem services, there are different ways to do. One way is to adapt the management by using close to nature silviculture. This means, this is well known, to increase tree species richness, to increase structural diversity, genetic variation within species, to increase resistance to individual trees, replace high-risk stands and keep average growing stocks low. This in theory, but we also could test future tree species in plantations. This as a basis for a step-by-step adaptation of today's forests or today's species to a changing climate. And this means an assisted migration approach. And here's the plan. The plan was planned, or like, let's say these test plantations started to be planned several years ago, and it is planned to test 18 tree species all over Switzerland in this type of plantation, as you can see here. One of the big problems is, as the climate change is proceeding that rapidly that trees cannot spread by natural means of seed distribution, the question arises how to bring the species to the place that will be suitable, have a suitable climate in 50 to 80 years. And this means we have to help these trees by assisted migration or assisted gene flow. And one of the applied questions here is, how can species grow already in these habitats that are now not really suitable, but will be suitable in the future? And more towards research, which are the factors that determine the performance of these selected tree species regarding these environmental gradients, and how large is the variation among the tree species. This means this intraspecific diversity of the provenances. We started by 62 species that were evaluated, including stakeholder consultation. There were some important criteria like the potential to provide ecosystem services as now, the ecological amplitude of the different tree species, also including risk, such as the susceptibility to pathogens and to drought, and also including invasiveness for alien species. So there is a set of these 18 species. There is a core set of 9 species that are planted in, let's say, 2/3 of all plantations foreseen. This is silver fir, sycamore, European beech, European larch, Norway spruce, Scots pine, Douglas fir, non-native, sessile oak, and small-leaved lime. There is also an extension set that some of the foresters can plant if they like, and in 15 such common gardens or test plantations, there are planted Italian maple, Norway maple, Atlas cedar, Turkish hazel, the 2 non-natives in Switzerland, walnut tree, wild cherry, Turkey oak that grows only in the south of the Alps in Switzerland, to a small extent, pedunculate oak and wild service tree. A test plantation looks like this. So think of a gap within a homogeneous area of forest, mainly consisting of one homogeneous site condition. 6 to 18 tree species are planted in 3 blocks, and tree species are planted in one field that is subdivided into 4 different subfields that are composed by 4 different provenances of the species. This sums up to 27 individuals per provenance and about 104 tree individuals per species. All these plantations are fenced to provide from browsing, and they have a distance of 20 to 40 meters apart from the existing forest. Just coming back to this upward shift that will take place by modeled by projections. So we will face an upward shift by about 300 to 500 meters that corresponds to about 1 to 1.5 elevational zones. So Switzerland in forestry is subdivided into these elevational zones, starting by colline zone, submontane, undermontane, upper montane, high montane, subalpine, and upper subalpine. And it is meant that, for instance, a beech tree individual can shift from, let's say, the undermontane belt to the upper montane, or even to the high montane belt, which corresponds to about these 300 to 500 meters. This is the geographical distribution of these test plantations. The map shows 57 sites. At the moment, this number has climbed to 59 sites in Switzerland. The trials are foreseen to last for 30 to 50 years. And on 35 sites, as I said before, 8 or 9 species will be planted. Silver fir will be planted on all sites. On 15 sites, there will be planted this set of extension species, and in total there are about 50,000 seedlings used for this study. This is the elevation, this is the distribution along the elevational belts in Switzerland. So we have like 15 test plantation at an elevation of 600 meters. So this refers to divide the big area in the central plateau. But we have also 3 plantations that are located at elevations of 1800 meters. I give you 2 examples. So in Mayan Fields, in the Rhine Valley, at an elevation of 580 meters above sea level, there are 9 core species planted. And in addition, there are also 9 extension species planted. Among these, 3 of these are really non-native, and 2 in orange are not native to this area, but are native in some parts of Switzerland. In addition, Douglas fir is also planted, but this is also has been planted in this area 100 years ago already. So the 9 core species here are all on place already. In contrast, if you look at the test plantation in Celerina, in the Engadine, at 820 meters above sea level, the set consists of only the core species, the 8 core species. And here we have in red 5 species that are not building forests in this area. So this is either the species have not migrated to this place, or the place is really with a too harsh climate that the species so far has not been established, could not establish at this place. So it will be interesting to see for how long the planted seedlings will survive at this area. Regarding the provenance selection, a water balance map was used, a water balance map of all months of the growing season having more than 5 degrees of average temperature. And according to this map, the trees with a higher negative water balance were selected to be used in these test plantations. So this was the concept, how to select for these provenances of the different species. And here are some impressions of these ongoing test plantations. Up to now, 10 test plantations are already installed, and the next will follow in this and the next year. In every of these test plantations, there is also a climate station installed that measures all the climate information. Now I come to the next problem, namely the alien problem. So as you could see, some of the non-native tree species that are widespread in our country were not selected for these test plantations, and this is because of the invasiveness status. For instance, black locust was not selected. This is quite clear. This species vigorously spreads in Switzerland and would really harm the biodiversity in the future if they would be actively planted in the forests. In contrast, Douglas fir is, of course, favorable future species in Switzerland. Here, this is a very new map produced by Silvio Schüler and Dave Chakraborty in a paper that will appear in the next few days in the Swiss Forestry Journal. It shows in gray the current presence of coastal fir, and on the right graph, the future distribution, projected distribution of the coastal Douglas fir. And you can see along the Alpine arc, higher elevations, higher up than 1,000 meters above sea level, the suitability is the best. So this is clearly a future species, but then also the problem arises, is there like a risk that this species will become invasive? Invasiveness, this would relate to the fact that such a tree species could build self-sustaining populations or could negatively alter the environment. We tested this recently now for Douglas fir in Switzerland. We found no self-sustaining populations so far. Douglas fir has been planted for the last 120 years in Switzerland, and we could not see populations that were self-sustaining outside of 100 meters apart from the mother trees. So by this definition, we find this species is not invasive. But we also checked in an extensive review consisting of 34 different studies comparing Douglas fir, pure Douglas fir stands with pure native stands, whether this Douglas fir has negative or positive impacts to soil conditions or to biodiversity. Regarding soil conditions, we did not find on productive stands negative influences of the Douglas fir presence. In contrast to biodiversity, for the biodiversity, we compared, in the different comparing studies, we found like a decrease in species richness regarding fungi, xylophagous beetles, tree-bound spiders, and other insect or arthropod groups. And in conclusion also for birds. This holds especially for birds that use Douglas fir or Douglas stands in wintertime. So there are almost no birds on these forests, on these stands. So this means that Douglas fir should be used in mixtures only, and larger plantations should be omitted. I come to my conclusions. By test plantation, the future tree species and the provenances will be introduced to these new locations where they could not reach in such a short time by simple natural seed spread. The test plantation will show us the success and the failure of the used tree species from the various provenances, and this will be, of course, an important information to be used as a decision support tool for the next decades. And it is also important to test the impacts of the non-native tree species to these native ecosystems, and these need to be tested and monitored. Up to now, I have not in my radar the Turkish hazel or so the different new non-native tree species that are now used in these plantations. So far, we tested the Douglas fir. Okay, and with this, I thank you for your attention.
Thank you very much, Thomas. This was really interesting, and I feel a little bit of pity that these kind of field studies are not part of our ALPTREES project. Maybe Katharina is willing to put another project in that goes then a little bit more into practice, and we can gain our Swiss colleagues as strong partners here. So thank you very much.
Indeed, very inspiring. Thank you very much, Tom.
Okay. Thank you very much for this really interesting presentation. And I just wanted to ask you a starting question before we go into the questions coming in through the chat. Did I understand right, and from your slides also, that you know exactly where these 0.5% of non-native tree species in Switzerland are located? Or is this an estimation?
No, this is based on the NFI.
Okay, so you identified this through the National Forest Inventory, and basically know the exact location. This is very interesting, of course, for all the other work that might follow from that. And so let me point to some questions from the chat, which basically refer to the design of your samples here. The first one is, do you also plan for test plots with interplanted or mixed species? This is from Arthur, and another one directly from Silvio, a little bit related here, who congratulates you also to your fantastic test design. And he asks if you could explain a little bit more with respect to the integration of the proveniences in your design. So maybe these two questions, if you could pick them up for the moment, and others are coming in the meantime.
I don't know exactly don't understand the question of the mixtures. So as you can see in the test plantation, the trees are not intermixed among each other. So they are planted in squares. They are by their own. So this maybe
probably possible interactions if you would mix them more and not basically have them too much in a small monocultural system. I can imagine is behind this question.
Yeah, okay, I see. Yeah, it's difficult. And the other one is, how about provenances? I mean, provenances were selected or purchased at different localities outside of Switzerland or inside of Switzerland, using, like, let's say, a next step of higher water balance. So this means that it was towards a more a search for more drought-resistant provenances within a species. So if we look at, for instance, Scots pine, we would collect Scots pines of the Spanish area, for instance, where we have, we presume that the water balance will be more negative than in Switzerland. Silvio, was this your question?
So
maybe.
Silvio, you want to clarify here?
No, I actually want to ask, let's say, how you distributed them across the trial sites, because you have so much huge elevational levels, and it's very important then to see where they are located.
Yeah, I cannot tell you this detail. Maybe Peter Brang is here. I don't know if he has more information on that. I could not see it in the.
Yeah, maybe we can chat on that later.
Yeah. Let's move on. There is another question, which again refers to the provenience, particularly of Abies alba. If there were also populations used from southern Italy, glacial refugia populations. So interesting question here from Matt.
It could be. Actually, it can be checked on the website. There's a website on test plantation, I think. And on this website, all this information is listed, even the provenances that are used.
Okay, and related to that, are there also some physiological parameters which are considered here in the tests? Do you know about that?
In which way? Because, I mean,
well, general plant physiological parameters, I guess, that are mentioned here. Probably we can also check this in the website Dev. This was a question by Dev from BFI here, BFW. And more comments that this is a great thing to really identify possibilities of going for assisted migration. This is a very positive trend. I think so too. Personally, this is super important because this is where we can help basically adapting the forest to climate in a quite fast and natural way. And the last question to you, Tom, what about mycorrhiza in planting new tree species? Any idea on that one? Very difficult, yeah.
I mean, it's a very good question, of course, yes. Actually, we also, we did once a trial with Scots pine, and we poisoned one part of the experiment so that there would not be any mycorrhiza, and the other one we used mycorrhiza. And during the first 2-3 years, there was no difference in growth. And there was only one exceptional drought, and after this drought, 1/2 of the experiment died. I mean, it can be very important, but maybe in more extreme situations. I don't know exactly for this. We have the soil conditions that are there on place and nothing else. There was nothing added by mycorrhiza. So.
Well, perfect. Thank you again, Tom. And assisted migration is the keyword also for our next keynote speaker. Silvio Schüler from BFW